My guest, Lily, what a great name for a garden enthusiast, asked me some
Well,
questions.
first, I am a mechanical engineer at a medical device company, so that is where my limited experience using Minitab comes from. And I'm also an enthusiastic but very, very amateur gardener. So yeah, as part of my job, I've attended some of the Minitab trainings with Jim, and he really loves to bring up some gardening examples, and I love the idea of using gardening as a way to showcase all the things that Minitab can do, and maybe even help me out with some of my gardening tribulations. So I'm excited.
I wrote down some of your questions on a little mind map of sorts, a thought map, if you want to call it that. And I wanted to just like run through it with you, maybe get some more questions
Sure,
from you, and
yeah,
we
let
could go
me
open Minitab and answer.
start.
The best measure of the size of garlic was my goal. And the things I did before was circumference, but some of the things that I didn't, think about while I was out there doing the job was like the new ones are all much more moist than the old ones. The old ones are all dried out, ready to eat. They're already cured or whatever you want to call it. And also the new ones are all dirty. So there's extra weight from something we don't want to measure on them.
Yeah, you'd really be putting your thumb on the scale, as it were, for if you were to just base it on that.
And then the thing you predicted in your note to me was like placement of the garlic on the scale, and specifically how you cut the top off, like all that stuff matters. I did do some of the weight measurements. And we could simulate that, just see how like my measurements would look in a Gage R&R for weight versus circumference. What should weight be? What should the transfer equation be? So that's what's on the right here.
Yeah, if it were like a perfect circle.
Yeah.
Which
it was not.
Which probably garlic isn't. So
not at all. Not at all. Some of them were crazy shapes, but I do think like estimating it as a sphere was kind of similar. So we could take a look at that too.
Yeah.
But you want to do some Gage R&R here?
Yeah. So okay. So you're saying that right now you have we're looking at the weight measurements right now?
This is all circumference. I haven't added the weight in yet.
Okay.
I took some, but
either way, so these specific measurements are ones that just you have done, correct?
Yep, just me. It's all operator Jim.
Okay. Oh, right. Yeah, it's right there. Okay. So, and then this is the thing, because I always mix it up, but so the Gage R&R measuring multiple times, like one person measuring something multiple times, that's the repeatability aspect of it.
Yep,
or do
absolutely.
I have it backwards?
No, you got it.
I got it. Okay, good. And reproducibility is having a different operator being able to be repeatable in their own right, but then also give similar results to the first operator.
Exactly. Yeah, the operators, that's the other R. So for Gage R&R, those are the two R's. You nailed it. Perfect.
Okay, so basically what you're saying is right now we have enough data to assess the repeatability R, but just not the reproducibility.
But exactly.
But at some point, we're thinking that you might be able to convince your wife to be our second operator.
I could, yeah. Actually, my wife and I went through black belt training together, and we help each other with our projects.
That you're the two like statistical gardeners.
Yeah. So for sure, like probably this weekend, we'll just do that. Like we'll do a little simulation. What if Laura does do this? What would it look like? All right, I'm gonna go number this to 12. I'm going to make all these Laura.
So basically all the Jim data is real, and then the Laura data is just kind of like fake stand-in data until we get the real data.
Exactly.
Okay.
Yep. And we'll fudge hers up a little bit so that there's some variation there so that we're not carbon copies of each other. Okay, 129 there. So I modified those two so they look a little different, but we're going to be super similar. Then to do the Gage R&R, you can go to right in here. It will load up parts, operators, circumference. And now that we have two operators, we're going to get a little different output. Ta-da! Let me show them side by side.
Okay.
This is Jim. This one's Jim plus Laura. Okay. Now check out the difference. So this one, where we're only able to look at repeatability, Now we're able to look at operators, part by operators, and repeatability. So these two things right here, that's going to be the reproducibility. And you'll see that down the other tables below.
Okay.
What other questions do you have about interpreting the numbers at the top or the 6-pack at the bottom?
Okay, yeah, wait. So let me just look at the numbers at the top again.
Okay.
Can you just walk through like the variance components tables?
There's a ton of variation driven by the parts, not much variation driven by these. If you wanted to look at that in a percentage, like that's what this table is all about. It's like this
Okay.
is the variance in the data driven by repeatability, reproducibility, and that reproducibility is actually broken down into operator and if the interaction existed, if it was important, it would show up here too. Let me show you another graph actually that would represent this pretty well. You can go to quality tools, Gage study. We can do a Gage run chart. Part numbers, operators, measurement. Yeah, so check this out. So this is like all our data here on a graph, just showing Jim in blue and Laura in red. And you can kind of get a feel for, like the average Jim is lower than the average Laura on every one of these.
Okay. Yeah, I like that.
So then as you go through and read these, we've got some rules that you can apply to this. Like it would be nice if your variance components were only a small amount of variation in the data set.
You want all of the variation to come from the parts themselves, not from your measurement method.
All this table is doing is it's trying to quantify like the variance of each level here and then put it into a percentage. So just like you said, you want this number to be very large and you want all the other ones to be very small. And that's what we have here.
Yeah. So probably, I mean, I imagine like most quality systems probably have a threshold for how much variation you're allowed to have from the measurement method. I guess, is there a general rule of thumb, or is it, I mean, it's probably very industry dependent, but.
Oh, there is. Let me bring you to one thing on Minitab's website where you or any of the people watching here can download this, keep a copy of it for yourself just so you can see the guideline. I believe it's on here. Let's check it out. Training, sample materials. I'll put a link directly to this so you don't have to worry about it. Yeah,
but yeah, while you're getting that up, because in my mind for this, I mean, first of all, if this is just for like somebody's own gardening, then it's the level of criticality is pretty low, I would think. But mainly what I was then interested in is just comparing the two. So rather than having an absolute threshold that you would have to meet, it's saying like, okay, well, if I'm a gardener and I just want to measure my produce, then which measurement method is going to get me the most consistent data? So that's where I would actually just be comparing between the two, and then we'd be looking at what's that operator dependent test method in general, non-part variation, and whichever one is lower would be the one that I would say like, okay, let's use that.
Yeah, perfect. And there's two ways you can do that. I'll explain just the rules here first, and then I'll show you how, like if we had weight in here, how you could compare the two, like which measurement system is better.
Okay.
All right. So for the existing data we have on screen now, like here is one that you could use for the percent variance numbers. Like under 10% for the measurement system would be acceptable. If it's over 30%, it's not acceptable. If it's somewhere in between, then look at criticality, just like you're saying. Like, yeah, if it's 10 to 30, you're probably fine.
Okay. Whereas like anything over 30% is kind of like, why are you even bothering to measure this? There's going to be so much variation here.
Exactly. Like if you had over 30% of the variation in your study was caused by measurements, you couldn't even tell the difference between more than a couple parts.
Yeah.
But here we can do a very good job.
Sense.
Yeah. So this number is much lower than 10%. We're like super good. Let's do this. So there are a couple ways that you could analyze this. One is just run the Gage R&R exactly like you already know from the class you took, statistical quality analysis. You could run it again, but instead of measuring circumference, you can measure weight. Okay, and we can compare study variance here versus what we had back on this one. Split view, there we go. So you can see it's like twice as bad.
Yeah.
And then another way you could do it, you'd have to take, if you were interested in learning more about it, you'd take another class. The next class after statistical quality analysis is advanced topics in, and then you can do Gage R&R for an expanded study. And in that one, let me zoom in. In that one, you can have parts, operators, and measures, just like we have in the regular, but you can have additional factors like measurement device. And it'll just tell you straight up how much variation comes from the measurement device.
Oh, okay.
Okay.
Yeah, I would love to see a video that shows that. Well, yeah, so you can use your fake data to play around with it, and then have your second operator perform it, and then do that comparison. Because yeah, I didn't realize that you could actually do like that Minitab could just do the direct comparison between the two. That's exactly what I was looking for in my original comment.
Yep. Now, a lot of times this one is going to be used like for the same actual measurement dimension. So it would be like you have weight here and you have weight here. You just have two devices measuring it.
I understand that. This is like a completely different measurement method. So it's yeah.
But you'd still be able to see really interesting things, even though it's going to say there's a huge variance caused by different measurement devices because you're actually measuring different things. It would also show operator by part interactions, operator by measurement device interactions. Like, does Jim measure circumference better than weight, for example? It would answer that.
Ooh, yeah, interesting.
So what else could I show? Oh, I could show the audience just this little thing here, like with the transfer equation, like what would we have expected for weight? I'll show that real quick. Do I have that up?
Yeah, but again, that's where I would love to see it with actual data and then see how close to the predicted transfer function do we actually get. When I'm, buying seeds or seedling plants or anything, usually they'll say, oh, this is how many grams or pounds or whatever of produce this will produce. Like I've been harvesting my cherries recently, and that's like when you buy the cherry trees, they'll say, oh, a full grown tree will produce 25 pounds or whatever it is. And so I've been measuring like my harvest with my kitchen scale, how many pounds of cherries am I getting? So so that's why in my mind that would be like that's how you would typically measure it. But then if you were finding, oh well, yeah, weight is actually not great for me because the actual measurement method, the scale itself, seems to have all this unexpected variability, but two, it means that I have to be really concerned about being consistent with when I'm measuring it, right? Because if I let some of them dry out longer, then now that's impacting my measurements. That's like this hidden variable that you typically, well, in any situation, you really don't want your measurement to be dependent on when you take it. And if they were like perfectly spherical, then I would say like, yeah, well, actually, don't take the engineering approach, just take the mathematical approach.
Here is the spherical approximation. Here's the columns I added to the worksheet to get, the weight, the theoretical weight from the circumference. Yeah. So it's like this one down here is if I have a density of 320 kilograms per meter cubed for garlic. This is a higher density. Yeah. And then this is where the new garlic is much heavier than the old garlic. This is a scale of weight versus circumference here. Just trying to map that transfer out. But yeah, I'm going to measure these. We'll compare it to the actual. Well, it was a pleasure talking with you. Thanks for having this with me.
I look forward to seeing the next video on the garlic series.